Hey everyone, welcome back. Today we're diving into a groundbreaking audio tech breakthrough that's redefining how machines listen to the world. Imagine you're in a bustling cafe, trying to hear a friend's voice over clattering dishes, chatter, and a blender. How do you separate that single voice from the chaos? That's the challenge of audio source separation, and a new approach is rewriting the rules. Let's break it down. Traditional systems tackle this problem in two steps. First, they detect what sounds are present, like a voice or a blender, then they try to isolate each one. But here's the catch, these methods often miss the timing of sounds. Think of it like trying to follow a conversation where everyone speaks at the same time. You need more than just knowing who's talking. You need to track when each sound happens. This research team tackled that gap by creating a smarter two-stage system. Let's walk through their innovations. First, they used a transformer, a type of AI model good at understanding context, to detect sound events. But they didn't stop there. They fine-tuned this model to not just spot sounds, but to track them over time. Imagine training a model to recognize a dog bark and know when it happens in a 10-second clip. That's what they did, using both overall clip data and frame-by-frame details. Then came the big twist, temporal guidance. They built a second model, trained on the same data, to give the separation process a time stamp for each sound. Think of it like a GPS for audio, telling the system, okay, the voice is here between 2-4 seconds, and the blender starts at 5 seconds. This helped the system align sounds more precisely, like a musician tuning their instrument. They also added something called embedding injection. This means taking intermediate thoughts from their sound detection model and feeding them into the separation process. It's like giving the system a cheat sheet of what to look for, making the separation more accurate. Oh, and they didn't forget about long-term patterns. By integrating a special RNN, a type of neural network, they help the system understand how sounds evolve over time, like how a song's melody changes or how a voice might pause and resume. But the real game changer: iterative refinement. Instead of doing everything in one go, their system refines its work step by step. It takes its previous guesses, tweaks them, and gets closer to the perfect separation. It's like editing a video, each pass makes it sharper. The results? Their system placed second in a major audio challenge, the DCASE 2025, proving these ideas work. And the best part? Their code is open source, so others can build on it. So why does this matter? Better audio separation means clearer voice assistance, smarter noise-canceling headphones, and even better speech recognition in tricky environments. It's not just about hearing sounds, it's about machines understanding the world through sound. But here's the deeper insight: this work isn't just about separation. It's about contextual awareness. By combining temporal tracking, iterative refinement, and embedding injection, the team created a system that doesn't just isolate sounds, it understands their relationships. This is a leap toward audio systems that can parse complex scenes, like distinguishing a baby's cry from a car alarm in a crowded street. The research also highlights the power of hybrid architectures. Transformers handle global context, RNNs manage temporal dynamics, and iterative refinement ensures precision. It's a testament to how combining neural network strengths can solve problems that single models can't. And the data. They tested on DCASE 2025, a dataset simulating real-world chaos with 94 interference categories, room acoustics, and background noise. By controlling exact sound timings, they trained the model to detect events with surgical precision. Metrics like café, a measure of separation quality and accuracy, showed their system outperformed previous methods by 1.7 points, with iterative loops boosting results further. This isn't just a technical win, it's a step towards smarter AI. Imagine a future where your phone doesn't just hear your voice, but understands the context of every sound around you. From healthcare monitoring patient vitals through ambient noise, to autonomous vehicles detecting emergency sirens in traffic, this tech has far-reaching implications. So next time you're in a noisy environment, remember, scientists are hard at work making that possible. Thanks for watching. Hit subscribe for more deep dives into the science behind the tech you use every day.